How to implement strategy pattern in ML projects. Learn how to use the strategy pattern in Python to create flexible and scalable ML algorithms. Welcome to our channel. Did you know that one of the key challenges in machine learning projects is maintaining flexibility and scalability as data changes? Today, we're diving into how the strategy pattern can solve this by allowing your algorithms to adapt seamlessly. This design pattern is essential for creating scalable, maintainable ML pipelines. Let's explore how you can integrate it into your projects and why it's a game changer.
The strategy pattern is a behavioral design pattern that enables selecting an algorithm's behavior at runtime. Imagine a navigation app that can switch between driving, walking, or cycling routes based on your preference. This flexibility is what the strategy pattern brings to software design, especially beneficial in machine learning projects. It consists of three main components: the context, strategy interface, and concrete strategies. By encapsulating algorithms, the strategy pattern allows you to interchange them without altering the client code.
In machine learning, the strategy pattern offers several advantages. Firstly, it allows you to switch algorithms at runtime, which is crucial when dealing with different data types or requirements. This pattern significantly improves your code's maintainability by decoupling the algorithm from the context. It also supports scalability, as you can easily add new strategies without modifying existing code. Furthermore, by adhering to the try, don't repeat yourself principle, it reduces redundancy and potential errors in your codebase. Let's dive into implementing the strategy pattern in Python. Begin by importing necessary libraries and defining a strategy interface, which acts as a blueprint for your algorithms. Next, create concrete strategies, which are specific implementations of the strategy interface. Implement the context class that uses the strategy interface to execute the desired algorithm. Here's a simple Python code example: Python class strategy, def execute self, data, pass class concrete strategy a strategy, def execute self, data, return strategy a executed class concrete strategy strategy, def execute self, data, return strategy be executed class context, def underscore init underscore self, strategy, self dot underscore strategy equals strategy def set underscore strategy self, strategy, self dot underscore strategy equals strategy def execute underscore strategy self, data, return self dot underscore strategy dot execute data. With this setup, you can easily switch strategies by changing the concrete strategy object passed to the context.
In this block, we'll apply the strategy pattern using Scikit-learn models. Suppose you're working on a classification problem and need to switch between different classifiers like decision tree classifier, random forest classifier, or SVC without changing your evaluation pipeline. By implementing the strategy pattern, you can achieve this modularity. Define a strategy interface that all classifiers will implement, then create concrete strategies for each Scikit-learn model. Your context class will manage the execution. This design allows you to easily swap models as needed, enhancing flexibility and maintainability. Switching algorithms at runtime is one of the most powerful features of the strategy pattern. Imagine a scenario where your machine learning model needs to adapt to new data characteristics quickly. By implementing this pattern, you can dynamically switch algorithms based on the data or external conditions, improving performance and adaptability. This is especially useful in environments where data is continuously changing, such as real-time data processing or adaptive systems. We'll demonstrate this with a Python code example, showcasing how easy it is to change strategies on the fly without compromising system integrity. Testing and validating your strategies is crucial to ensure system robustness and reliability. Begin with unit tests for each concrete strategy to verify their functionality independently. Next, perform integration testing to ensure that the strategies work seamlessly within the context class. Employ validation techniques such as cross-validation to assess the performance of different strategies. This testing approach helps identify potential issues early, ensuring that your system remains robust and performs optimally even when switching strategies.
Integrating the strategy pattern into your ML pipelines can enhance flexibility and streamline workflow. In Scikit-learn, pipelines are used to automate the workflow of data preprocessing, model training, and validation. By incorporating the strategy pattern, you can easily switch between different preprocessing or modeling strategies within the pipeline. This integration allows for seamless transitions and adaptability to new requirements or data changes. We'll walk you through an example using Scikit-learn's pipeline class to demonstrate how this integration enhances your ML projects. The strategy pattern is widely used across various industries for its flexibility and adaptability. In finance, it allows for dynamic investment strategies based on market conditions. In e-commerce, it helps personalize recommendations by switching algorithms based on user behavior. We'll explore case studies of successful implementations of the strategy pattern in machine learning projects, highlighting the challenges faced and solutions implemented. These real-world examples demonstrate the pattern's potential and offer valuable insights into its application across different sectors. We've explored the strategy pattern's role in enhancing flexibility and scalability in machine learning projects. By implementing this pattern, you can create adaptable algorithms that meet evolving data requirements. We encourage you to apply these insights to your projects and share your experiences in the comments below. Don't forget to like and subscribe for more in-depth tutorials. Stay tuned for our next video, where we'll dive into another exciting topic in machine learning design patterns.